All right, so this video is going to finish up the homework assignment. It's going to finish up pages 20 and 21. We did page 19 on the last page. So this one's just going to go over pages 20 and 21. So we have a 3 kilogram cart is moving. So we have our mass is moving east at 24 meters per second. So I have a direction and I have a velocity. We don't know what it is yet. Could be final, could be initial. What constant force would take it to stop the cart in 2 seconds? So stopping is a phrase here that you got to make sure you're looking out for. So that means VF is going to be 0, which makes this 24 VI. That means you're looking for force, and I gave you time. Okay, so if we're looking for force equals mass times acceleration. So F equals our mass, which is 3. Acceleration, didn't get it. Okay, so what we're going to do is we're going to set up our Daffy T to figure out. So A is your question mark. Okay, VI is 24, VF is 0, and I gave you a time of 2, so that means we did not care about distance. So you're going to use equation number 1, so VF equals VI plus AT. So 0 equals 24 plus A times 2. So move that 24 to the other side, becomes negative, and then divide both sides by 2, and you get an acceleration of negative 12 meters per second squared. Now, as I have my A, so I'm going to bring it over here. So 3 times negative 12, and I'm going to get negative 36 newtons. Or, since I gave you a direction, you could also say 36 newtons west. Either one would work in this situation. Number 5, how far would a curling rock slide? So that means you're looking for distance. If the initial velocity is 3 meters per second, so there's VI, and the force of friction between the rock and the ice is 4 newtons. So this is where this one can get a little bit tricky, is you got to look at what's being said, is how far would it slide? So that means VF is going to be 0 because it's got to come to a stop. Okay, and then it's a frictional force. Remember, friction always goes against you, so we're going to make this a negative 4 newtons. So there's your force. Okay, and I gave you a mass. Okay, so I want to know how far would it slide. So that means we're looking for distance. So that means we would have to set up Daffy T to see if we can get it. So D would be your question mark. Okay, VF would be 0. VI would be 3. Okay, I don't have time. Okay, and I don't have A. Okay, so what we're going to do is we're going to find A so I can bring it over here because I have force and I have mass. So F equals MA. So negative 4 equals my mass, which is 20 times A. So divide both sides by 20, and you get an acceleration of negative 0.2 meters per second squared. It is okay to get a decimal. Okay, you're just talking about a rock sliding on ice. Okay, it's not going to take very much to bring it to a stop. So your acceleration is negative 0.2. So what I'm going to do is I'm going to bring that over here to my Daffy T. So negative 0.2. That means I did not care about time. So you're going to use that fifth equation. So VF squared equals VI squared plus 2AD. Okay, so 0 equals 3 squared plus 2 times negative 0.2 times D. Okay, what I would do is I bring that 3 squared over. It becomes negative 9 equals, and 2 times 0.2 would be negative 0.4 D. So divide both sides by negative 0.4, and you're going to get a distance of 22.5 meters. 6, a 3 Newton force north and a 4 Newton force south act on a 0.5 kilogram mass. Okay, determine the acceleration of the mass. So there is no Daffy T here. We're just dealing with forces and mass. Okay, so what I'm going to do is I'm going to kind of illustrate this. So I have an object. I have 3 newtons going north, so 3 newtons going north, and I have 4 newtons going south. Okay, so remember F net equals mass times acceleration. So we got to figure out what is our net force. Okay, so I'm going to find the difference between the two, so basically 4 minus 3. That means it's going to be a net force of 1 newton, and it's going south. So 1 newton equals mass times acceleration. So my mass is 0.5 times A. So divide both sides by 0.5. And I get an acceleration of 2 meters per second squared, and that is going south. Okay, so that's all you had to do on that one. Number 7, a force of 20 newtons, so I gave you force, Acting on a mass of 5 kilograms, there's mass. Going 10 meters per second, we don't know what that is. We're just going to say that's V. The force is acted for 3 seconds, so there's time. What is the final speed of the mass? That means you're looking for VF. Okay, so that means this is VI. Okay, so what we're going to do is we're going to set up Daffy T because we're looking for VF. VI is 10. Okay, my time is 3. Okay, and I don't have enough to do it, but I have a force and I have a mass. So 20 equals 5 times A. So divide both sides by 5. And the acceleration of 4 meters per second squared. Now I can do is I can bring that over to Daffy T. So bring that over. That means we did not care about distance. So we're going to use equation number 1. So VF equals VI plus AT. So VF equals VI, which is 10, plus A, which is 4, times T, which is 3. So basically, in this case, 10 plus 12. And that's going to give me a final velocity of 22 meters per second. B, how far does it move during this force? Okay, while it's acting on it. Okay, so what we're going to do is you're just going to do Daffy T again. So it means you're actually looking for distance. So what I'll do is we're just going to flip-flop. Okay, so basically what we're going to do is we're going to put the question mark on D now. And final velocity we're going to cross out. Okay, now, could you plug in final velocity? Yeah. You just got to choose something to leave off where you can find distance. It doesn't really matter. Okay, just in this case, I'm just going to flip-flop. So A is still going to be 4. VI is still going to be 10. Time is still going to be 3. So we use equation number 3. So D equals VIT plus 1/2 AT squared. So that goes, the VIT goes away because never mind. Just be careful with that. See how it's easy. I could do that. So if VI was 0, you would do that. But in this case, I made a mistake. So VI would be 10. Time would be 3. Plus 1/2. A would be 4. And T is 3, and that's squared. Please just square the time. Don't square that whole thing. It's just the time. So if you add all that up, you should get 48 meters. Last one, I have a force of 100 newtons, so I have my force. Made a mass speed up from 10 meters per second to 20 meters per second. So VI, VF. During this time, the mass went 150 meters, so there's distance. What is the mass of the object? So you're looking for mass. So F equals MA. F is 100. Mass we don't know. And we don't have A. So what we're going to do is we're going to set up Daffy T to find it. So we're looking for A. Okay, VF is 20. VI is 10. Okay, and my distance is 150. That means we did not care about time. So you're going to use equation number 5. So VF squared equals VI squared plus 2AD. So 20 squared equals 10 squared plus 2 times A times 150. Okay, so that basically comes out to be 400 equals 100 plus 300A. Okay, move that 100 to the other side, it becomes 300. So 300 divided by 300, and you get acceleration of 1 meters per second squared. Now I know A, so I'm going to plug that in over here. So 100 equals mass times 1. Divide both sides by 1. You don't really have to do that. And you get a mass of 100 kilograms. And that will end that one.